Hi, everybody. My name is He Shuang. I'm here to present Duumviri detecting trackers and mixed trackers with a breakage detector. Many of you have used content blockers to protect your privacy, such as the ones shown on this slide. The way they work is by checking requests against filter lists, such as Easy List and Easy Privacy. Those filter lists are human-written. They basically contain a bunch of rules. If a rule matches a request, then that request is simply blocked. The problem with this approach is that, first of all, scalability. For every new type of a tracker, a privacy developer has to come along, investigate the issue, and adjust the rules accordingly. And because they are human-written, privacy developers can make mistakes, blocking non-trackers. Previous work, they have tried to come up with automatic tracker detectors, drawing features from various sources. Most notably, the most recent work, they treat the web page rendering as a graph, involving interactions from entities such as HTML elements, network requests, and JavaScript executions. They draw features from this graph to make tracker predictions. The problem with previous works is that they can break a high percentage of web pages. This work specifically breaks 15% of pages. To me, a tool that has this high percentage of breakage is really not usable. Duumviri, we're trying to address the high breakage issue, and we found two main reasons behind the breakage. First of all, there may be cases where functional request is being misidentified as trackers. And if you block a functional request, it can break pages. The root cause behind this is because previous works, they are trained from filter lists. And as I said before, filter lists are not perfect. If you train a model from this imperfect data source, your model is likely to make errors. And I like to point out it's hard to improve the quality of this data set because there is already skilled workers working on it every day. The second reason where a breakage can occur is because functional information can be mixed into a request with tracking-related information. In this case, we call it mixed trackers. Let's see one example. This is an example of a mixed tracker. This is a request that gets sent out after a user clicks on a specific item from the search page. And this request contains 3 parameters. The first 2 help redirecting the user to the exact item that she wants to see. But the third parameter, it contains high entropy identifier. And this is a mixed tracker because if you block it, then the user clicking on the item will no longer see the page does anything. The page basically becomes unresponsive. But if you allow this request, then it hurts user privacy because of the transmission of the third parameter. We proposed Duumviri. We try to address the high breakage problem. We realized that tracker detection is never solely about how many trackers you identify. It is also about how to avoid breakages. To this end, Duumviri proposes a two-modeled approach for tracker detection. In addition to a regular tracker detector, which answers the question whether a given request is a tracker, it proposes, designs, and implements a breakage detector, which answers the question whether blocking a given request breaks the page. Now, in Duumviri, a request is a tracker if the tracker detector is positive, indicating that it is a tracker, and the breakage detector is negative, indicating that blocking it does not break the page. Well, there might be cases where both detectors are positive. For instance, where the tracker detector is positive and the breakage detector is positive, indicating that blocking it breaks the page. This can happen due to mixed trackers. But due to the time constraint of this talk, we won't be exploring it. It is explained in detail in the paper. So the benefit of having this breakage detector is that it allows the tracker detector to be tuned much more aggressively, identifying more trackers. When a misidentification occurs, this breakage detector can can pull back the misidentification and increasing overall tracker detection accuracy. In the rest of the talk, I'll be talking about the design of this breakage detector. Again, this breakage detector is a machine learning model that we trained to detect breakages. We had to first define what is a breakage in the context of tracker detection. We defined it as changes that you apply to the vanilla unbroken version of the page, and these changes must be significant enough for a human user to call it a breakage. Therefore, we model breakage using differential features, comparing a changed page to its vanilla unbroken version of the page. An equally important problem we have to address was how do we collect samples of breakages. We need many instances of this unbroken version of the page and change the page. Obviously, we can't crawl the web to collect breakages because they are extremely rare, and we don't want to craft breakages as that can skew our results. So, Duumviri collected breakages samples by studying exception rules. This is a type of rule that privacy developers insert into filter lists to temporarily fix breakages. Let's see one example. Starting from the very beginning, privacy developers has identified that abc.com is a tracking domain, and it inserts a rule there to say any request from that to that domain should be blocked. However, user has reported that a breakage has happened on example.com. The cyber weak deals section loads indefinitely. A privacy developer comes along and investigates the issue and has realized that this particular resource is not a tracking resource. It is a functional resource, and is blocking it causes the web page to break. Therefore, privacy developers temporarily fix this issue by inserting an exception rule with the preceding email signs, stating that any request going to abc.com should not be blocked on example.com. We looked at this exception rules, and we realized that it is possible to reconstruct breakages from exception rules. Let's see how Duumviri does it. Starting from the exception rules, Duumviri will visit the site specified in the exception rule. It doesn't use the exception rule, though. It turns it into a flipped rule, turning it from a block rule into allow rule into a block rule, blocking the exact resource that the privacy developers previously identified to be critical for the breakage. Blocking this resource allows Duumviri to reconstruct the breakage. Now, the benefit of this approach is that, first of all, there are many instances of exception rules, and they're extremely relevant. We proved this point by looking at the reconstructed breakage and see how many cases match exactly with the user reports. And we found that Duumviri was able to handle all the cases, while previous work was only able to handle around 85% of cases. There are 15% of cases where they think the breakage reconstruction was proper, but the reconstruction was actually not. As I said before, a good breakage detector should help with tracker detection because it can pull back misidentifications. We proved this point by conducting a large-scale tracker evaluation on 15K pages. We got 96.53% accuracy when using filter lists as the ground truth. As I said before, those filter lists aren't perfect. So we did a disagreement analysis, and it shows that Duumviri was correct in 55% of cases where it indicates it is a tracker. Because Duumviri uses this breakage detector, it is able to detect filter list caused breakages. In the example shown on the bottom half of the slide, when you have easy privacy turned on, the entire page body is missing from the user interface. This case has been reported to the privacy developers and has been addressed. We also did a comparison with previous work. We see that they have extremely similar accuracy when using future list as the ground truth, but through a disagreement analysis, Duumviri was correct in 70.5% of the time when the two tools disagree. In conclusion, Duumviri proposes a two-modeled approach for tracker detection. In addition to a regular tracker detector, it proposes a breakage detector, which detects when the web page is broken due to tracker misidentification. We trained the breakage detector using exception rules, but we believe this breakage detector will be helpful for other tasks where usability is a concern, such as phishing detection. Duumviri can also detect mixed tracker automatically, but due to the length of this talk, is covered more in the paper. Duumviri has gone through artifact evaluation and has got the reproduced badge. All the code, model, and data is available from this URL. Thanks.
Hi, I'm Chris Tycho from CISPA. I have a question about the breakage detector. So how do you envision that we can query this model for websites during interaction with users, right? So they click around, and for each of this UI change, would you query the model, or how does the breakage detector work in real time, right?
Right now, it is static. So you given it a page, you given it a changed page, it will tell you whether the change applied to it is significant enough to be called a breakage.
Okay, but could you maybe evolve that to support also user interactions? Because there it would be very hard to obtain training data, right?
That's right. So it is our future work to consider almost like a time lapse of features or like changes that you applied to the page and use that to build our breakage detector.
Okay, thank you very much.
Thank you.
Any other questions? I can shoot another one.
Go
if
ahead.
not, yeah. So about do you only support normal HTTP requests, or do you also support other protocols for kind of preventing trackers, like, I don't know, WebSockets or things like that?
At the moment, it's just HTTP requests, but I know that tracking can occur on other protocols such as WebSocket. One future work would be to support that, but I don't think anything special that needs to be done for Duumviri to support that. But it's just we haven't supported it.
Okay, thank you very much.
One more question. Hey, thanks for the talk, Eric Wistro, University of Colorado. I'm curious how you see this shaping the arms race between advertisers and ad block and how that would go forward. Could they use similar techniques to automate bypassing your automated system to detect them and sort of find ways to inject in a tracker despite this defense?
That's right. So the question is, maybe a server can adopt to what Duumviri does and try to evade detection, for example. So I think Duumviri's implementation, the tracker detector, for the tracker detector part, it uses one of the features that it uses flow-based features. So flow-based features basically means if there is data flow from data sources such as cookie jars, and it's going to sinks such as the network, then it draws features from such data flow. It has been proven to be quite robust because if you have to conduct tracking, you have to send information somehow. And I was just going to say Duumviri doesn't really do anything extra, but it's already using quite proven robust features. It will be interesting to see if people will try to evade the detection of the breakage detector. For example, you can say it will try to make the breakage detector think that any changes applied to the page is broken, and thus it won't flag anything as a tracker. That's entirely possible, but we think we have tuned this breakage detector enough so that any additional changes will be considered a broken page. So this means that if a server is willing to sacrifice functionality to enable tracking, well, they might as well just say, either turn off your app blocker or do not enjoy my service. I think to that point, I think it's hard to say it's still necessary for any of the tracker detector to work. That's my personal feeling.
Awesome, thank you.
Thank you.
Let's thank our speaker.